Alrighty, let's try some harder problems now. We have copper reacting with silver nitrate to produce copper nitrate and silver. Go ahead and pause this video and try to solve it on your own. Alright, hopefully you attempted the problem by yourself. Let's do it together. We have one copper on the left and one on the right. We have one silver on the left and one silver on the right. And as for the nitrate, the NO3, it's easier to treat it as a unit because it makes balancing the equation much easier. So on the left hand side we have one nitrate, and on the right hand side we have two of the nitrate. So what we need to balance here is the nitrate. Least common multiple of 1 and 2 is 2. So we need to introduce a coefficient of 2 in front of the silver nitrate on the left hand side. So now we have 2 silver and we have 2 nitrate on the left hand side. The coppers are still balanced, there's no issues there. The nitrates are now balanced. We have 2 on the left, 2 on the right, but the silver is not balanced, so we need to balance the silver. Again, least common multiple of 2 and 1 is 2, so we need a coefficient of 2 in front of the silver on the right hand side. So let's just check our work. We have 1 copper on the left, 1 copper on the right, 2 silver on the left, 2 silver on the right, and we have 2 of the nitrates on the left and 2 nitrates on the right. Potassium reacts with water, H2O, to form potassium hydroxide and hydrogen gas. Again, go ahead, try to solve this problem on your own, and let's do it together now. On the left, we have 1 potassium. On the right, 1 potassium. On the left, 2 hydrogen. We have a total of 3 hydrogen. 1 as part of the potassium hydroxide, and 2 as hydrogen gas by itself. And then we have 1 oxygen on the left and 1 oxygen on the right. So what we need to balance first is the hydrogen. Total, we have 3 hydrogen. So the way we're going to balance the hydrogen is, let's think, what number can we make the hydrogen total on the right hand side that is going to be compatible or divisible by 2. So let's say we introduce a 2 in front of the potassium hydroxide. So now we have 2 potassium on the right, we have 2 oxygen on the right, and now we have 2 hydrogen as part of the potassium hydroxide. So total, instead of us having 3 hydrogen atoms on the right hand side, we now have 4. So now the total number of hydrogens we have on the right hand side is 4. The least common multiple of 2 and 4 is 4. So we need to multiply this hydrogen by 2 by introducing a coefficient of 2 in front of the water. So now we have 4 hydrogen on the left and 2 hydrogen on the left. 2 oxygen on the left, I mean. So we've balanced out our hydrogen by having 4 hydrogen on the left, 4 on the right. We've balanced the oxygen by having 2 on the left, 2 on the right. And now the only thing we need to balance is the potassium. We have 2 on the right, 1 on the left. So that's an easy fix. Just introduce a coefficient of 2 on the left hand side. Potassium reacts with diboron trioxide to produce potassium oxide and boron. On the left, we have 1 potassium, 2 boron, and 3 oxygen. On the right, we have 2 potassium, 1 boron, and 1 oxygen. Let's start by balancing the potassium. Least common multiple of 1 and 2 is 2. So we need a coefficient of 2 in front of the potassium on the left side. So the potassiums are balanced. Now we need to balance the boron. We have 2 on the left, 1 on the right. So let's balance it by adding a coefficient of 2 in front of the boron on the right hand side. So great, now that's balanced. And now to balance the oxygen, we have 3 on the left, 1 on the right. Least common multiple of the 2 is 3. So we need a coefficient of 3 in front of the potassium oxide. And so now we have 6 potassium and 3 oxygen. So we've balanced the boron, we've balanced the oxygen, but now we have to go back and balance the potassium. And we do so by introducing a 6 here. So now our equation is balanced. Sodium reacts with sodium nitrate to produce sodium oxide and nitrogen gas. On the left, we have a total of 2 sodium, 1 sodium by itself, and then another one as part of sodium nitrate. So a total of 2. Normally, I would tell you to view the nitrate, the NO3, as a unit. However, if you look on the right hand side, we don't have a nitrate present. So in this case, it's easier to break up the nitrate into nitrogen and into oxygen. So on the left hand side, we have 1 nitrogen and 3 oxygen. On the right hand side, we have 2 sodium, 2 nitrogen, and 1 oxygen. The sodium is already balanced, nothing to do for that. Let's go ahead and try to balance the nitrogen now. Least common multiple of 1 and 2 is 2. So let's introduce a coefficient of 2 in front of the sodium nitrate. So now we have 2 nitrogen on the left, 6 oxygen on the left, and a total of 3 sodium on the left. So we've balanced the nitrogen. Let's go ahead and try to balance the oxygen now. We have 6 on the left and 1 on the right. So let's introduce a coefficient of 6 in front of the sodium oxide. And so now we have 12 sodium on the right and 6 oxygen on the right. We've balanced the nitrogen, we've balanced the oxygen. Now we need to balance the sodium. So we have a total of 3 sodium on the left and a total of 12 sodium on the right. So to make things equal, we need a coefficient of 10 to get 12 sodiums on the left.